you very much, and thank you for joining this afternoon. I hope it will be worth your while. My name is Erik Petersen. I'm a 40-year veteran of the marine industry. I'm a naval architect, and I have a PhD in maritime human factors. I've been working in the marine industry. I've been doing ship designs. I've been doing research. I've been doing marine electronics with a large company that I won't mention for 20 years. And then 5 years ago, I went back to university, and I'm now a senior researcher at the University of Western Norway. I'm also the coordinator of the Ocean Project. So that's who I am. So let me tell you a little bit about that, and if I can make this work. Yeah, okay. So the Ocean Project is not typical in the sense that we don't start with an agenda of fixing the seafarers to make everything work. We actually believe that the seafarers are very, very good at what they do, and it's people who are well trained, who are working in a difficult regime, who are doing their very best to make life at sea safe. So this is where we come from. This is sort of our key agenda. But of course, there are still accidents happening. And when we speak about accidents in this context, we are confining ourselves to navigational accidents. And we are even just looking at collisions. We're looking at groundings. And then we're looking at two, you could say, different aspects of navigational accidents. And that is ship whale strikes. And it is the risks posed by containers lost overboard by container ships. So these are the elements that we're concerned with. And we are also coming from the point that we believe that at the end of an event, there might be a human who did something suboptimal, but this is a function of organizational factors, it's a function of technology, it's a function of human factors, but they gang up. And we are believers in what is called the Swiss cheese model, so that you cannot just have an accident because a single thing goes wrong. It's always a chain of events, but it's a chain of events that may start very, very early on before an accident. It leads up to an accident. So this is what we look at it. But in many cases, the real accident, it comes from a loss of situation awareness. Comes from poor decision making in that moment in time. It might be accidents waiting to happen. It might be designed to happen, or more or less. But we are very concerned with situation awareness. So it is a question of advising the mariners that there is a risk in a timely way, and in some cases, it's also a question of giving advice on how to get out of the problem again. So this is sort of our you could say, basic beliefs. And ocean, in this case, it means operator-centered enhancement of awareness in navigation. And that is something where every word here counts. And let me walk you through that. So first and foremost, we are thinking about navigation and navigators. And like I said, it's very high on our agenda to make the navigators more aware of risks in time, and it is a question of advising them on evasive maneuvering in time. So this is what we mean when we say navigation in the ocean context. We are, like I said before, we are user-centered, we are operator-centered. We put in our way of working, and this is also why it's so important that you are here today, in our way of working, we want to put the navigators into the center of the development, into the center of the thinking of what we do. We see, like I mentioned before, that improvements are probably needed across the entire, what we call the socio-technical system. So it is about organization, it is about training, it is about working conditions, it is about how people feel, it is about, of course, human limitations, and so on and so forth. But we are looking at the entire range. We're not just focusing on what is called human error. We are trying to learn from past problems, but we are certainly also trying to learn from past successes. in what David is doing, looking at training. We are very keenly involved in looking at what are the people who are making good training doing differently. So what can we pick up from that? What can we share across the industry? How can we share best practices? And then we are designing for people, and that is where human-centered design and human factors knowledge comes into the game. So that we make solutions for seafarers and not have engineers make solutions for engineering, because this is what is often the case. And then when we talk about situation awareness, we are using the word maybe a little bit differently than what has become the norm. When I hear the word situation awareness being used in the marine context, in the maritime context today, it's very often a question of looking out the window. Then you have situation awareness. And we disagree a little bit with that, or we have a wider definition. There is a literature on situation awareness, and it consists of perceiving an issue, comprehending an issue, and projecting it. And it is the projection that will help you make the right decision. So understanding what is going to happen, what is going to go down now, is really the point. And that can be supported by design. And this is what we want to do. So we want to introduce design that is more conscious of situation awareness and is helping the navigators in the sharp end of the business make better decisions. So this is what ocean means. And I will not bore you too much, but we have sort of three clusters of activities. One is concerned with the work system. I've already been mentioning the work system and how we look across it. So we are looking or re-looking, I would rather say, at navigational accidents, trying to understand root causes, but in a wider context than what you typically see in accident investigation reports. We are looking at operational successes. I mentioned design of training based on understanding what does good training mean, what is best practice in navigation. I think we are all concerned with the use of ECDIS and how that can be improved. And we would like to share that, especially with people like you. So putting things into the IMO, putting things into interest organizations, raising the awareness about these findings is high on our agenda. This is an entirely busy diagram, and I don't expect you to see everything on it, but many of the risks we are talking about are things you can't see. I mean, sailing along in a fishing boat at night, maybe in bad weather, you will never detect that semi-floating container that is lying out there. You will never evade it because you won't know it's there. And it is very much the same with marine mammal ship strikes. You don't see the whales. So how on earth can we blame the navigators for not avoiding them? The whales themselves, they don't care. They are not aware of the ships. They don't see the ships as risks. They don't hear the ships because there's a silent cone in front of the ship. So the whales are going about their business, and they are, by the way, very single-minded, it seems. If they're feeding, they're feeding. If they are looking for a mate, they're looking for a mate. And they are not distracted by other risks like maybe like humans are. So this is one of the things we need to find a way of detecting the whales, and we need to find a way of detecting the floating containers. And all of that will go through this magical system of IT and will end up back in the front of the navigator. So what we're going to do is that we will take those observations and we will reissue them as navigational warnings, or even as virtual ATONs on people's ECDISes or chart plotters. And we can do that more or less in real time. This is at least our belief. So there is no added investment for the seafarers. There's no added investment for the owners. There's simply what we hope will turn out to be a more intelligent use or a use of an infrastructure that is already there to put these warnings and into the face of the navigators to help them comprehend that there is an issue. So this is what this diagram tells. We are going to use crowdsourcing, so people observing things. We are going to use satellite-based image analysis. We are going to use reports. We're going to use hydrophones to listen for marine mammals in areas where we know there's a high concentration. And we are fusing all of these data sets to provide warnings. One thing that we see is of particular interest is the IMO BIMCO initiative on mandatory reporting of lost containers. This has a very, very high, this would have a very high impact, that there is actually a mandatory notification of containers going overboard also in international waters, because that would trigger this entire system. And then we can start to use satellites to watch out for them. We can start to use drift modeling to figure out where they will be. We can start to issue much more accurate warnings to the seafarers. And it is especially here the softer seafarers we're looking at. So like I said, yachts, fishermen, little ships, etc., are those that will really benefit from this. But they are also so many that they can help fuel the system with their observations to the benefit of everybody else. So this is where the crowdsourcing element comes in. There's so much talk about autonomous shipping, and the Ocean Project is not one of those. We are not thinking about autonomy. We are thinking about augmenting the seafarers. We're thinking about helping the seafarers do what they do. And we do have a work package that is looking at whether it is feasible and sensible to have some kind of automatic evasive maneuvering in case there's no response from the bridge team. But that is the trigger, that the system knows something is going wrong, but unless the bridge team is not responding, then it might kick in. We're looking into this, but this is the only, you could say, automatic function that we have here. The rest is based on people-technology interaction. We have set the challenge quite high. We are going to demonstrate this we're 6 months down the line in a 3-year project. So in 2.5 years, we are going to demonstrate all of this, and we are going to demonstrate it at technology readiness level 7, which is as high as you can go in a research project. It's just before things start to go commercial or starts an industrial rollout. So the technology, the systems, the infrastructure will be there. It will be demonstrated. And we will show how single observations can actually propagate to show up in front of the navigators. And we will demonstrate improved situation awareness. And all of you, in case you like, are so very welcome to follow what we do and provide input and talk to us and help us get this right, because we are certainly not, we don't have any patent on being correct here. We have our convictions, we have a thrust, but help us direct it. So this is also why you're here today. And yeah, I'm stepping ahead of my slides. We have a Maritime Stakeholders Forum, and it's open. You simply sign up on our website, or you contact David, or you contact me, and we will set you up for that. We also have, for those who are more keenly interested in technology, a subgroup where technology is going to be a bigger issue. You can just subscribe to our websites, to newsletters, to webinars, etc., etc. But we are really trying to engage anybody out there who have a valid opinion and good advice to offer. So a little bit about who we are. I need to say that these problems, I couldn't resist myself introducing you to the term a wicked problem. And that is a term for problems that are fluffy and where you don't really know when you have solved them, or you don't know how much you have improved. And they are also characterized by, they are not vertical. You need other facets, you need many facets in order to solve them, because there's not a black and white solution. So what we're looking at here is very much a wicked set of issues. And the key point here is that you need an interdisciplinary or multidisciplinary team to involve it. So here's a little bit of commercial. Nautical Institute is involved. Teledyne is involved. They are experts in hydroacoustics and underwater sensing. Chimne is a Spanish university, experts in databases and data infrastructures. Kystverket is the Norwegian coastal administration. Oceanos is a group of whale experts, marine mammal experts at the University of the Azores. We have the University of Catalonia. This department are experts in AI-based image analysis. Kongsberg, I don't think I need to introduce who Kongsberg are. The university, the Technical University in Athens is involved. This is the department that are looking at maritime economics, and they are helping us assessing impact of accidents and rating root causes. Lloyd's register is involved. I think it's also, I don't need to introduce Lloyd's. IWDG is a small group, the Irish Whale and Dolphin Group, which is, again, experts on marine biology and helping us to understand what the marine mammals are doing. And then finally, Irish Ferries, which are operating between Ireland and the UK and Ireland and the continent, and they are also operating container ships. They're helping us both on, they're the end user, they're the real end user. They're helping us seeing this from the navigator's perspective and supporting us. So this is who we are. And just to wind down, like I said, it's a complex project. It's multidisciplinary. I told you what ocean means. It's clear that the challenges we are trying to address, they are persisting. We will deliver more usable things. We will deliver tools for the industry to try to improve. And I'm so proud of the team that we have here. I'm sure that the diversity and the knowledge of that team, they can actually have an impact. So that's it. This one could remain, but thank you for listening, and please reach out to us in case this is interesting, in case you can contribute or just want to put the nasty question to us that we can't answer. Those are the best. So thank you very much, all of you. Thank you.